Hi, everyone. Welcome to today's past performance virtual group. I got to remember to say group and not chapter. That's a hard habit to get out of. Hopefully you guys can see my screen okay. I know it's it's a little squished up there and not quite right. It's not showing the whole screen, but you'll get the gist of the content here. So I'm your moderator today, Leslie Weed. Here's our Twitter hashtag website discussion list email for the performance group. Please feel free to reach out to us if you'd like to speak, would like to have a specific topic. We can always track people down to talk about things. Kevin always has tons of topics, so we can always track him down again. Okay, just a reminder, if you are new to GoToWebinar, if you need assistance, please raise your hand. I'll try to answer your question in the background with private chat. We do recommend you maximize your screen, and feel free to type in your questions, though we are going to hold questions to the end, but feel free to type them in at any point in time, but just know we are not going to answer them right away. We will hold them till the end. And just a reminder, please use audio through your computers. There is no dial-in number. Virtual groups. So hopefully everybody's a member of PASS, and if you're not, you should definitely be one. Totally free. Go out to pass.org, I believe, and you can become a member, and you get a lot of good content. A lot of good newsletters come out, and just access to so much for learning and sharing and networking. So lots of different virtual groups out there. And let's see here, Summit 2019. Wow, it feels like we just had Summit.
Mm-hmm.
So Summit 2019, registration starts January 24th. Lots of good topics, lots of good time, Summit 2019. So if you guys need to get in your conference or learning requests early, look at Summit and plan for that. So that's going to be early November usually, or last week of October, first week of November. It's usually in those dates, and I don't know them offhand. Data expert series. So there will be some data expert series you can sign up for. They're going to be covering a lot of this past Summit content. So we've got an architecture stream, a data management stream, and analytics. So lots of good stuff there. And that's going to be a whole day on February 7th. So you can kind of tune in and tune out on things that really interest you on that. Oh, this is a scary one. This is me. I'm going to be the pop-up expert this month, which is very, very exciting. So hopefully you can join me. I'll probably talk a lot about data vaults. Data vaults, cool. So hopefully you guys can join me on January 30th at the end of the month. Okay, upcoming SQL Saturdays. We've got quite a few going on. Costa Rica BI edition. I really should have submitted for that. I really should have wanted that. As I look at the snow outside right now, I'm thinking, oh, that sounds really good.
It does.
All right. PASS is looking for some sponsors to help with some of the virtual groups and some of the other content and webinars that they host. So if you have a contact, know of anybody that might be interested, refer them over, and you'll also get a $100 gift card. So anybody that might know of somebody there. Great place to grow your career. So again, join PASS. Lots of different ways to share and learn and connect to people. And there's the SQL information, pass.org. So if you're not a member, definitely become a member today. Lots of good things going on there. And that is it. So I'm going to make Kevin our presenter. And then we'll get started. Kevin is now presenting.
All right, let's see. Okay, can you see my desktop coming through there?
Absolutely, looks good.
Okay, thanks so much, everyone. I appreciate you carving out some time to spend it with me today. I know you have a lot to do, a lot of demands on your time, so I really appreciate it and want to express some gratitude for that. Also, I do want to say I ran through this content a little bit earlier in the day. It took 65 minutes to get through, so I think it might take us a minute or two over the hour allotment. That's why I've asked that we hold the questions till the end. If I don't get all of the questions answered, I promise to answer all of them in email, and I'll probably do a follow-up blog post as well. And I put the answers up there because a lot of times if you have a question, that means 2 or 3 other people also have that question and they haven't voiced it yet. So that's the way I typically like to do things there, make sure everybody gets the benefit of that. So let's take a brief commercial interruption. I do want to take just a moment to introduce you to my company, SentryOne. I started there as person number 14, and now we're almost 200. And we have a ton of products. We're known in the industry as producing or putting out the best of breed, the most informative across the broadest spectrum of features of SQL Server, and that's really reflected in our passion. We have 7 Microsoft MVPs on staff, which is more than any vendor in our space. So we're really into people knowing exactly what's going on inside of SQL Server. The thing I really want to point out and really, really proud of, though, is over here on the right-hand side, we have just crazy numbers here, crazy good. We're the top 1%, not just of our industry, our niche in the industry, which is called application performance monitoring. We're in the top 1% of software companies in terms of customer satisfaction, customer loyalty, and our relationship with our customers. 50% of tickets get resolved in 1 hour. I have friends who, go with other vendors for different products, and they're like, yeah, I hope to get an email within a week, and there's no chance of getting a bug fix. Another thing I like to point out too is Trust Radius. I like to point it out because it's a cool service that everybody should know of. Trust Radius is to enterprise software what Amazon reviews are to things like screwdrivers and CDs and books. If you've ever been the kind of person who reads reviews and say, oh, that was helpful, they told me this screwdriver doesn't fit that person's hand well, that's good to know. Well, that's what Trust Radius is, but for everything enterprise software related. Things like, say a backup and recovery system, or a virtualization management system, or a SQL Server monitoring system. We have by far the highest score on Trust Radius. And again, one of the highest scores of software vendors out there. But this number is actually out of date for 2019. Just this month, it's been up around 9.1, which is almost unheard of. It's just crazy good. So if you're looking for a tools vendor, please do me the honor of giving us a shot and considering what we have. We have a ton of products. The one I really like to brag about is called Plan Explorer. Everybody, if you write SQL code on SQL Server, you want Plan Explorer, and it's so free. We don't even ask for an email address. Just download it, start using it. Just a couple other highlights. Doc Express is our product that does automate your documentation. It traces your data lineage, so it can tell you that it came from this SSIS job, from that Oracle server on this and such date into this local table. Really cool things like that. And then there's SQL Sentry, our monitoring and alerting system that is par excellence. No one gets close to what this product can do, and at as low an overhead as we do. Just as kind of a special offer from me, if you are interested in any of these products, I can get you a full 1-year license for them if you want to give them a try. It's called a seed license. All you got to do is drop me an email and I'll work that out with you. All right. One other thing, we do have some really great resources. I'm going to refer to SQLperformance.com from time to time. It's a website from us, has a lot of independent writers and experts on there, but it's all about choices between multiple alternatives and how they perform compared to one another. You'll definitely want to take a look at that. A couple 100,000 distinct readers every month. Century1.com resources, that's where you'll find a ton of my videos. I think I've got maybe 10 hours of query tuning videos of different kinds there. There's white papers, there's ebooks, there's all kinds of great stuff. And then blogs.century1.com, that's where our team writes about things they're up to, things they're learning. So you can see where I'm speaking, for example, and what I'm up to. My name again, Kevin Klein. You probably know me, if you know me, then you probably know me either through one of two avenues, either A, as one of the original founders of PASS. So 9 of us got together and formed PASS back in 1999. And I was also president of PASS from 2004 to 2008. So you might know me from that. Also, you might know me from my writing, books like SQL in a Nutshell, or maybe my monthly column in a magazine called Database Trends and Applications. And my personal request to you would be, if you're on social media, let's connect on Twitter and LinkedIn. That's how I get the news out, and also things that I'm learning and reading. So I'd like to share online there. So what are we going to learn today? 10 surprising performance killers on SQL Server. We're going to start at the lowest level, hardware, OS, and configuration. We're going to work up from there to database design. We're going to then go into SQL and transact SQL code. And we're going to spend a few minutes in closing on system settings. The reason I geared it that way is if you look at this chart that Gartner put out in 2008, we see that performance issues on Microsoft SQL Server databases typically have a kind of a diminishing return the further left you go. How you set up the Windows OS and the hardware is pretty small. Maybe 10 to 15% of the total amount of performance bottlenecks arise from that area. System settings here, the SQL Server system settings, that's maybe in itself a distinctive 5%. But once we get to the database, the design of the database, and the application, meaning the SQL and transact SQL code you run against the database, that easily makes up 80% of the performance problems. So I'm going to start here at the left and work our way over, and we're going to dive into a bunch of patterns and anti-patterns that cause performance issues. And also the idea here is, if you're reading blog posts out there, and I hope you are, there's lots of great ones to read. Many times the blogger doesn't really put things into perspective or put them in context. So they might be telling you this performance tip, and it seems very important, and it seems like it's something that should be pretty easy for you to implement. But they don't tell you that this only affects, the 1% most busiest SQL servers out there. Or conversely, some other thing that seems like it's a lot of work, and maybe I don't want to do it. They don't tell you that this affects 90% of SQL servers, and that the performance boost you get from that change is very substantial. In other words, they don't help you prioritize what these savings in performance might be. And so that's what I'm trying to do today, is to present to you a bunch of these really big ones, some that are not well known, so that if you implement all of these, or at least become aware of them as issues, you will get substantial double-digit performance increases without doing anything else but providing a remedy to these problems. So the first one I want to kind of set the stage is, I do work with high-end customers. And so sometimes you really have to push the limit to find out that these different bottlenecks exist. In this case, one of the customers I like to point to is a big bank out of London. They have one particular application that does tens of thousands of transactions a second. And those transactions might have multiple SQL statements within the batch. So this is not IOPS, this is transactions. And on top of that, all of the SQL servers, 800 SQL servers in this one application, all of them are arranged in availability groups for high availability. And so that means they're moving a lot of data across to the secondaries and so forth. And so if you popped open the task manager, here's what you get. Have you ever seen anything like that, Leslie? I know when I looked at that, I was like, holy moly, this is nuts. Turns out the first couple CPUs here, they are dedicated entirely just to network traffic. That's all those first couple CPUs do. It's bananas. So, how do you cope when you have a system like this? Well, the answer is Of course, the true answer to all technology questions is it depends. But let's start from the beginning. One of the very first things you have to do is you have to recognize that most default settings inside of Windows and SQL Server are antiquated. Most of those defaults were set up at a time when there were much different performance thresholds, and they are perpetuated through to today when those defaults no longer apply at all. And so the first one that I find over and over and over again is that the default setting for power plan, or sometimes called power scheme, on Windows Server, at least in my reference, all the way up to Windows 2016, I haven't checked on newer releases, it's set to balanced power. That's the default. The problem is if you have a CPU, and it varies whether it's AMD or Intel, but if you have a CPU set at balanced power, you're actually only getting 78% of that CPU's total capacity. Whoa. Yeah, you've already cut out 25% of your CPU's total available processing power. Make sure you get in there, not just into the raw OS, but you want to go into all of your VMs as well and change that to set to 100% high power plan. And that will give you a CPU boost right there. Another thing to keep in mind too is that for the last 10 years or so, the way that CPU processor manufacturers have added more power to the processors is not by making this chip speed faster, it's by adding more cores to the chip. And so, we at one time we had 4 core chips, and then 18 and 12 and all these other numbers, 32 cores. The problem is certain things in SQL Server are single threaded. And so even if you have lots and lots of cores, they can't take advantage of a multi-threaded workload. This is especially true on the not relational engine parts of SQL Server. So like analysis services, integration services, reporting services, those sorts of things have a lot of stuff in there that is single threaded. Many of the major workhorse components of SQL Server are multi-threaded, but some of them are still not. And so every release, they add a few more things and rework them so that they are multi-threaded. But keep that in mind. Upgrading to the newest CPU may look like on paper it's going to give you a lot more power, but because of your workload or maybe the way the application was written, you don't get it. So the trifecta of hardware is memory, CPU, and I/O. So memory, you'd think, is usually better, or is always better. I don't say always though, because usually is the case. When it's not better is when your database is smaller than the amount of RAM you have. Now, most of us, this isn't an issue because our machines are a little bit old and RAM is really expensive. So, we've got a 200 gigabyte database and we have 32 gig of RAM. So yeah, adding more RAM is absolutely going to be better there. But in the last few years, you're able to buy a server with 2 terabytes of RAM. So it is possible to fit all of your, your 200 gigabyte database into that server that has 1 terabyte of RAM. So adding another terabyte won't help. Another thing, though, that will help, and you may not know this is another one of those surprising performance killers, is that if you are used to setting up SQL servers, you will know that the memory settings, there's only 2 of them, really. There's the minimum memory and the max memory. There's a couple others around index creation and some stuff like that, but those are kind of edge cases. You don't need those too often. But by leaving these at the default, you're actually putting a performance bottleneck on your system. The reason for that is that every time SQL Server is going to make an adjustment to memory, if this value is set at the default, that number is equals out to 2 terabytes, or it's the theoretical maximum limit for Windows. And so when it sees that theoretical max, the problem is that the algorithm inside of SQL Server looks at that and says, hey, you know what? That's pretty rare. I don't think you actually have 2 terabytes of RAM, Miss Big Talker. I don't think you've got that. So I'm going to go out and do a CRC check and and make sure that you actually have that much RAM. And so that means you can experience more paging under those circumstances, and SQL Server definitely will use more cycles if you just leave these numbers at the default. Don't do that. Take whatever the maximum memory of the server is, and assuming that your SQL Server is set aside just for SQL Server, then you need to take out at least 2 gigabytes for Windows. If you've also got analysis services and other SQL Server services in there, subtract out memory for them. And then if you do lots of other things on there, then you should also take out additional memory for those other services as well. There are a couple other settings that you see pop up that can affect performance. For example, lock pages in memory. It's somewhat controversial. The reason for that is some people believe in it. Some people think you should not do it. And I'm kind of in the middle, actually. It does have one prerequisite. It requires Windows setting of large pages. And what it does is when SQL Server grows its working set size of RAM, it never reduces. It will never give back RAM to other operations, non-SQL Server operations on the SQL Server. Now that's great if you know the workload and you know there's nothing else running on that SQL Server. But if you don't know the workload, I recommend that you turn it off, because there's no telling what might come up at some point that somebody asked the server to do, and those other processes will be starved of memory. Another quick note too, by default, the SQL Server engine, this is surprising mostly to sysadmins, not as much to DBAs or well experienced SQL developers, but SQL Server doesn't grab the amount of maximum memory that you've defined when you start SQL Server. It starts out small, and as the different users request memory, it loads the data that you've asked to be cached into the cache, fills that up and says, oh, I've been granted a max memory of 64 gigabytes. I only have 20 gig loaded. Somebody asked for another table. Let's go ahead and grow the working set size and add more. So you might see that there are times when it's well under this number. If you're on older versions of SQL Server, particularly before 2012, another not well-known fact is that it had a different memory manager. And it also calculated the amount of total memory it used differently. So if you were looking at Task Manager, and God help us if you are using Task Manager to manage your SQL Server, don't do that. But if you were to use it on earlier versions of SQL Server, you would say that SQL Server might say that it has 8 gigs of RAM, but when you look at Task Manager, it says it has 10 gigs of RAM. And the reason for that is earlier versions of SQL Server counted stuff up differently. And so some of the smaller caches, say CLR, for example, it didn't count that in that total number. It only counted the data cache as what Task Manager could see. So keep that in mind. Also, one other big issue with SQL 2000, or before 2012, was that you could hit serious issues of internal memory pressure. And what I mean by that is in older versions of SQL Server, you probably know that there are multiple caches. There's the data cache, there's the plan cache for procedures and so forth. There's sort caches, there's hash buckets, there's log buffers. There's lots of ways SQL Server pre-allocates memory. And in the older versions of SQL Server, those caches had kind of fixed percentile numbers. And it would say the plan cache really needs to be 20% of the total RAM available to SQL Server. Well, the only problem there is, depending on your application, you might need 25% to comfortably accommodate all of the plans. However, the data cache is sitting there only using 80% of the total allocation that it has. So you might have situations on those older versions where one cache is starved of RAM, even though another cache has surplus. So keep that in mind, because those older versions have more constraints there. And that's one really good reason, besides the fact, one really good reason to upgrade, besides the fact that 2008 and 2008 R2 are going out of service soon. So I/O, again, looking at those high throughput systems, looking at the wait statistics. Wait statistics really are a great place to start your performance troubleshooting process. And they don't solve problems for you, but they help you get into the right bottleneck. And so when we look at one of those high throughput systems like this one, what we see is storage is often the top problem in terms of wait statistics. So here we see a wait stat on page IO latch _sh. That means shared, which also means a select statement. So what this is saying is we're doing select statements. The data I want is on the IO subsystem, not in RAM. So I have to grab that data, issue a latch, which is a reservation in memory. It's kind of like a lock, but it's very transient and ephemeral, very, very fast. And I'm loading up the data from the IO subsystem into the cache. Then you can see IO completion. We see page IO latch exclusive. So that means any of the write operations like an insert, an update, a delete, a merge. So that's up there. And then write log, so all the transactions being written to the disk subsystem. Those are our IO bottlenecks. In fact, talking to my buddy Bob Ward, who is head of the SQL Server customer support group and things like, he knows what's happening with end users out there. He says that about 10% of their calls at their help desk is about IO throughput and performance on SQL Server. If you haven't studied much about wait stats, take a look at century1.com/resources. We have white papers, videos. For example, there's a video there with Paul Randall, my go-to guy, the topmost authority in my opinion on all things SQL Server. So he's got a video there with Andy Yun, one of our solution engineers and a Microsoft MVP, and they talk all about wait statistics. So lots of additional information there for you to learn more. So here are a couple things about the IO subsystem I want to make sure everybody knows. The first is, if you're working on a newer version of SQL Server, you have probably heard that you need to have multiple database files. And why is that? Well, I'll illustrate this in a example using TempDB. What happens is inside of a database file, there are all of these objects that span data pages to help SQL Server find its way around that file. So for example, one is the PFS, that's the page free space. And those appear about every 64 megabytes or so. And this helps SQL Server see all the spots where there's empty space where it can write data. And so anytime you do a write operation, it can quickly scan those PFS pages to see where it can write data. When it's doing read operations, SQL Server will consult a couple objects called the GAM, the SGAM, and the IAM. So those last two letters are the allocation map. This is the global allocation map for things like tables. Then you'll see IAMs, which are allocation maps for indexes. And those appear every 4 gigabytes in the database file. So what happens is that end users will connect to the application, and anytime they need to do any work, reads are down here at the bottom, writes are up here at the top, SQL Server has to issue a latch to do a lookup to find out where that space is or where the table or the index is. And those latches, as I mentioned, are super fast. So that's not a problem when it's just one or two of us or a couple dozen of us working on a given database. But what if there is 300 of us or 3,000 of us? What we find on those SQL Server databases and also on TempDB is that these pages in the database file begin to really accumulate a massive amount of latch weights and slow people down. So the way to get around that is to actually allocate multiple database files. My recommendation is to start with 4. If you still have latch weights, go to 8. If you still have latch weights, go to 16. But in my testing, I see it plateau pretty heavily at around 16. You'd have to have a really highly stressed system, possibly a really highly stressed system and running on older hardware and OS and versions of SQL Server before you would have a need to go to 32 database files. But what happens is when you split this across 4 files, we now have 4 times as many PFS pages and GAMs and IAMs and so forth. So we just naturally kind of spread that load out and alleviate a lot of that pressure. In the newest versions of SQL Server, they make that the default to TempDB. I encourage you to also make that the default for your database files. Now, another thing I want to mention, another secret performance killer that most people don't know about, is how SQL Server does its write algorithm to databases. And it uses something called a round-robin proportional fill algorithm. So what that means is, let's say we have one file. SQL Server is going to do all the writing to this one file. But what if we have 4 files? Well, SQL Server will use the round-robin portion of this. And what it does is it starts with a write on the first file, and then it gets another write request, so it goes to the next file, and then the next write request to the next file, next write request to the next file, and the one after that goes back to the beginning. So it's round-robin, getting passed from one to the next as the requests come in, and helps distribute the load. What about proportional fill? What does that mean? So what that means is it fills up each file according to how much space is free. So if I only have one file and it's now 80% full, then I go in and create a second file that's 4 gig in size. It's going to proportionately allocate 8 writes to this one because it has that much more free space, and 2 writes to this one before it goes back to file 1 on the proportional. So what you see is a very imbalanced workload. So it writes and writes and writes to file 2, then a little write on file 1, writes and writes and writes to file 2, little write on file 1. Oh, we're almost out of space. Let's add another file. So again, we get this really imbalanced load where all the writes are going now to file 3 and a tiny bit to file 2 and a fraction to file 1 and on. So what you want to do is you want to pre-allocate the space that you were set aside for your database. And again, my default is 4 database files. I create them all of the same size, 4 gigabytes. Also, turn on trace flag 1117, which tells SQL Server anytime one of these auto grow all of them in the exact same way. Another trace flag I recommend is 2371. And that says, when you do your auto update statistics, don't use the default algorithm. The default algorithm is that the index has to change 20% or more before it will update statistics. And if you have really big tables, that could mean months and months of waiting for a refresh on those statistics. 2371 changes that algorithm so that it does it in a proportional way, so that the bigger the table, the lower the number has to be of changes before it will do an update. So on a well-designed system with round-robin proportional fill, what we have is each file getting a pretty much equal number of writes and growing it the same way, distributed load, stability, and predictability. And this is the way we want it as database professionals. We don't want any surprises. So that's the database file. What about the transaction log? Well, and I want to give a hat tip to Kimberly Tripp and the team at SQL Skills. The main thing you want to be aware of on transaction logs is twofold. First of all, transaction logs don't see a benefit from multiple files. I'm okay with seeing a transaction log that has multiple files only because that transaction log filled up a drive, and the only way to keep the database open was to create a second transaction log somewhere else so that you could truncate the first log. That's an acceptable reason to have more than one. In the latest release of SQL Server as well, they added a new special feature that most of us won't need to use that can benefit from having a second transaction log, small transaction log file for certain tail of the log operations. But generally, again, don't need it. What you need to pay attention to is auto growth and kind of unrestricted management of your transaction log. Transaction logs are set up to grow at a ridiculously low number by default in versions of SQL Server before 2016 and before, I should say. And so what happens is every time SQL Server auto grows that transaction log, and it's a very low number, it creates something called a VLF, a virtual log file, and it inserts a couple bytes in here, a few bytes for a LSN, a log serial number. And it has to initialize the next VLF each time it goes along. And the default is a percentile growth. So that means by the time you're getting to, let's say, a 1 gigabyte transaction log file, it probably has, 800, 1,000 VLFs in there. And the next auto growth will be fairly substantial. And that initialization process means that no write operations can be performed until it finishes. So you might have end users waiting. That's the first thing to be aware of. The second thing to be aware of is that these 8K little buffers, there's a limit of the buffers, 128 per database. And so you may have log buffer waits when none of the buffers are available. And then finally, the really big reason, in my opinion, isn't the day-to-day OLTP processing of these databases that are, have thousands of VLFs. The real part that makes me worried is recovery. So you're going to recover a database, even if you've been doing your backups right and all that. Each VLF LSN takes a little bit longer as it goes through the recovery process. I had a buddy who had a database of around 1 terabyte, and before they hadn't paid attention to their VLFs. And so their recovery, after they tested their recovery, saw how long it took. Then they rebuilt their database, rebuilt the transaction log so it could be the full size that it has sometimes had to grow to in the past. So that just had 1 or 2 VLFs. And the recovery for that 1 terabyte database was about 80 minutes faster. 80 minutes, more than an hour faster for recovery. And recovery is when the chips are down. That's when the CIO is coming to your office and saying, when's my server going to be back up? So you really want to pay attention to that. When does this start hitting you? If you have 300 VLFs or more on a given high performance OLTP database, you will begin to be able to notice that difference. It may be small, it may be sub-second, but it's going to start accumulating and growing from there. I've visited customers who had 50 and 60,000 VLFs. And when we rebuilt those databases, they were noticeably faster, even to end users who don't time things, right? It wasn't just something that you only notice with a stopwatch. All right, so let's move on. The important thing to remember with storage is that there are a couple ways to fix your problems. The first way is the way people usually try to do it who are not really well educated on SQL Server and how SQL Server works. And that is, let's just throw more hardware at it. So we're going to buy more storage, we're going to buy more hard disks. Maybe we're going to buy, separate the transaction log and the data file. We're going to segment out of these particular end user database and TempDB. Maybe we're going to get faster disks. They could be spindles or they could be SSDs. Maybe we're going to get a flash array. And also maybe we're going to get more memory because again, the more memory you have and the more of the database that fits in memory, the less buffering you have to go back and forth between the IO subsystem and the cache. So yeah, okay, you can do that, but why not work smarter instead of harder? One way we can do it is just to write better SQL statements that don't do select star without a where clause, right? The less memory, the less records and the less columns of the records that you grab, the less you stuff into memory. And, I'm surprised by how many developers think that this is revolutionary, but it just makes sense. You can only fit so much data into cache. And so if you're just using all those shortcuts, I'll load it all in and then I'll use the front-end client to filter out records I don't want, you're doing it wrong and you're hurting performance. Another thing I do see is people trying to save a buck by having multiple applications on a single box. Maybe it's SQL Server and analysis services. Maybe it's SQL Server and a middleware. Again, all of those things need RAM and they will be starving SQL Server for RAM unless you have enough for the database to fit inside of. Another thing that surprises a lot of people is that tightening up your clustered index can actually give you an enormous amount of space back in your database. And what I mean here is a lot of people in designing databases like to use composite keys. Sometimes those are called surrogate keys. And so let's say we define a clustered index on a table about people. We define the clustered index for that as last name, first name, date of birth, and social security number. Well, what happens is that's a pretty long string. Let's say that's 100 bytes in length. It turns out all 100 bytes of that clustered index must be included in every single row of every non-clustered index on that table. Wow. Well, suddenly I've gone from a few hundred extra bytes on each row in one table to, if this, let's say it has 10 indexes, non-clustered index on it. Maybe we've got, it's now 10 times as big. So beware if you do that. Instead, what you want to use is a natural key, something like an integer, a big integer, have a monotonically increasing integer ID. And then if you need that other surrogate key, you can create that as an alternate key with a unique constraint on it. And that way you get the best of both without actually causing this massive bloat in your non-clustered indexes. So that means you get a lot of space back in the cache. And then another thing, this is a massive low-hanging fruit, surprising performance killer, is the number of people who don't use data compression. Now, I can understand if you're running on older versions up to SQL Server 2014. Data compression was only available in those versions of SQL Server if you were running Enterprise Edition, okay? And SQL Server 2016. However, if you're licensed for 2016, just apply Service Pack 1, and you get lots of awesome features, including data compression, even on Standard Edition. Now, why is this such a big deal? We have a long series of blog posts that, if you look at this category here, written by Melissa Connors, one of our senior members of technical staff there. And she's done elaborate testing and just produced some great information for you to consume if you really want the details. The gist of it is, in a normally running OLTP application that doesn't have a really, really high ratio of update statements, the CPU overhead, in other words, the CPU cost that it takes to enable data compression, runs at about 0.6 of 1%. That's right, it's not even 1%. It's nearly 1% overhead on CPU. And yet the IO cost savings ranges from 40 to 60%. So all those weight stats that related to IO would have been greatly reduced if that particular SQL Server had data compression enabled. Again, I've done a presentation on this with Melissa. She's done a presentation on it. So you can see videos of it, slide decks on century1.com/resources. You can read the blog posts that were the foundation of those presentations. But gosh, you're just leaving performance on the table if you don't enable this. All right, and another thing, I always like to joke that, when I worked a lot with SANs, the SAN admins always told me that the SAN was the panacea. It was the cure-all to all my performance problems. And what I found was that the SAN was the central location of all my problems. And so, the SAN admins don't necessarily give you what is best performing on their SAN. They frequently will give you what is least expensive. So they might give you some disks that are arranged in a RAID 5 array instead of a RAID 1 array. And RAID 5 arrays take 3 times as long to process write operations as RAID 1 arrays do, 311% in my benchmarking. That's because they have to write parity bits on RAID 5. And so it can be a lot slower there. Maybe they are, it has tiered storage. And so there's, at the bottom level, there's cheap 7,000 RPM hard disks. Then in the middle tier, there's 15,000 RPM hard disks. Then there's SSDs, and then there's RAM and cache. And they decided to give you the lowest tier, right? So this is the kind of thing where I encourage you to trust what they say, but verify and make sure you know what your performance is. And again, you've got to go through the whole fabric all the way back to the SQL Server. So there's lots of places where things can be misconfigured and can slow you down. All right, so let's move on. Let's talk about some red flags for database design. Now, there's a couple things I look for. This is when I'm doing code reviews of internal projects, when I've got a vendor product that I'm thinking about buying, or maybe I'm comparing between multiple vendors who all run on SQL Server. For example, do they have inconsistent names? Maybe they have three-part names instead of two-part names, a schema and database, a schema and object rather. Maybe they have a field called email, and the field named email appears in the table for employees, the table for contractors, the table for vendors, the table for customers. But in one, it's varchar 100, and another it's varchar max, and then another it's, I look for those inconsistencies because that tells me that I'm probably going to run into other problems. I mentioned some problems with primary keys if they're not well defined. Conversely, you want all your defined foreign keys to have a non-clustered index. And I also see databases where there aren't any foreign keys. And the developers say, well, that's not a big deal because I put a non-clustered index on the column that acts as a foreign key. Well, it is a big deal because it turns out that when the optimizer sees a foreign key, it can do all kinds of additional things for certain kinds of queries, different simplifications, different bindings and things like that, than it can for the same thing that only has an index. And so, in other words, you get better performance when you have both of those, a foreign key and an index, declared together. There's also a couple kinds of problems that tell me that the database design could stand a little bit of scrubbing, particularly around indexing. So if I see a massive number of forwarded lookups per second, forwarded records per second, or key lookups per second, that tells me that there's probably some work to be done on the indexing within this database. In particular, forwarded records only happen if there are heaps in a table. And so again, generally speaking, not all heaps are bad, and there are certain situations where you might want a heap, but if it's an OLTP heavy application, you don't want to see a lot of heaps, particularly on the bigger the tables. So let's do a quick demo. I'll talk a little bit about key lookups and some of the other things that these scripts that I have set up for you will reveal. So let me find my let me find my deets here in my SQL Server Management Studio. So some database design red flags. I mentioned, naming. One of the big naming no-nos is if they begin any object with SP underscore. So if we see any object name like that, let's say code DB. Well, I don't have SP underscore, so I'm okay. If I have SP underscore, that's actually an inherited convention from the old days of Sybase, when this was a Sybase code base. And it doesn't mean stored procedure, it means system procedure. And it tells SQL Server to look first for the object in master rather than local database. And so that means you're going to waste some cycles every time you have an SP. Here's a little, I'm going to come back to this. I'm going to come back to incompatibility here because I actually see that I've got implicit conversions in the wrong place here. Inconsistency in our data types. This is some code written by Ian Stirk. He's a consultant out of London. And what this will show me is if I have any data types of a specific name, say city and state, and if they're vastly different one from the other. Generally speaking, the same named objects should be the same, right? You should have consistency here. And this is important for city here, because notice one is a varchar and one is in varchar. I'll explain that one in a moment. Another thing to look out for, oversized columns. If we have columns that are char when they should be varchar, that we could potentially be giving up a ton of space. But in addition to that, what if the average size of the the data in that column is way bigger than it needs to be? So here's a table, or I'm sorry, a column that is 5 in length, but the max size it can actually sustain is 20. Well, we're wasting half of that space. Let's flip over to another database here and say Doc Express. So here we've got one column that is 255 characters in length, but the biggest thing in it right now is 7. Again, maybe we can change that so that it consumes less space. If nothing we have in there of the millions of records is bigger than 7, that's a pretty good indicator that I might not need to worry about that too much. I've got a lot of code in here that helps reveal improper use of indexes. This one's from Davide Mauri from Italy. And taking a look at this just shows me whether I have a lot of heaps, maybe whether it's clustered or non-clustered, and some things like that. Here we can see if we have some tables that don't have a primary key. There's other things to tell us if we have some opportunities to apply additional indexes. Also, what happens when we have tables that have multiple indexes on the same column? I'm not sure that I have any examples in my database here. Yeah, I do. Well, when that happens, you create additional work for the system that it doesn't need to do, okay? It looks like these are, it actually pulled back some inconsistent results here because these are on different tables. If it happened to be on an index on the same table, then this would be something that you would want to drop one of those 2 indexes, because every time SQL Server has to do a write operation to your clustered index, it has to update every non-clustered index. So it's a lot of extra work. And here are a few red flag perfmon counters that I like to keep an eye on that tell me a little bit about the condition of the database design. For example, if I have a lot of forwarded records, I want to know. If, as a percentage of my total batch requests per second, I have a lot of table scans, I want to know. Let's see, what else do we have here? Here, I can see how many files, database files I have for a given database. This lets me know if I have, a good number, multiple databases. And then here's another one that will actually tell me how many VLFs I have per database. Oops, I already created the object. But in a nutshell, this will actually tell us, this particular database has 500 VLFs, that sort of thing. All right. So let's move forward. So I mentioned database design. Let's talk about database code quality. Implicit conversion is a major situation. It's a big deal. What this means is that SQL Server had to cast the data type from one to another for you behind the scenes. I'm going to demonstrate that in a second. A couple other red flags I look for is if we see GUIDs on the clustered index. This is a massive problem, and it is almost always done by people who are poorly informed of what to do, or because they used ORMs. Now, the most recent versions of Entity Framework don't do this as much, but Hibernate does it all the time, and older versions of Entity Framework do it all the time. It causes massive problems. Explosive number of page splits, massive fragmentation, and when you're troubleshooting, it's really, really hard. There are things in the way we code where we might not have good plan reuse. There are things that people do with CTEs, cursors, and triggers. All of those are good in their place, their proper place, which is to use sparingly and only when necessary. But you'll see applications where all of the application logic is, built up in a zillion triggers. Not good. All kinds of work is done through temp tables and tempdb. Again, not necessarily the best way to do it. All their data access is done with cursors. There are definitely times when a cursor is a good way to go, but there are plenty of situations where using cursors will take away performance and it'll end up shooting you in the foot. So again, let's go a little deeper into implicit conversions. This is a special situation where you have told SQL Server to use one data type that looks like it's compatible with another data type, but it's really not. For example, if you say in a stored procedure that a particular variable, let's say, is varchar, but the variable refers to a column, you're going to use it as a filter on a column that's defined as in varchar. SQL Server, you'd think, would have full compatibility between these two, but varchars are normal encoding, so they're 2 bits per digit of the string that's stored. In varchar is Unicode, and so they're 4 bits per digit of the string. And so SQL Server actually doesn't know what to do with this unless you explicitly cast it as a varchar, or one as the other, I should say. The varchar is in varchar or the other way around. So that means SQL Server has to figure out to do it for you implicitly behind the scenes. Oh, I think I know what you mean. You wanted me to do that, so I'll go ahead and do it for you. The only problem is it causes a lot of extra CPU. And the test, again, run by Jonathan Kahayas, I think this was SQL Server 2014. It really spiked CPU on a big batch. It went from 165 down to 15 requests per second, so it dropped by 11, a factor of 11. The same batch went from a minute to over 10 minutes, so it went up by a factor of 10, and it spiked CPU. What the heck? Yeah, it's really, really expensive. Plus, it screws up your execution plans, which I'll show you in a demo in just a second. Now, it's not just varchar and in varchar. It's anything that has an in, okay? Anything that has a Unicode compared to anything non-Unicode. It's also anything that has a max size limit. So if you do varchar 8000 and say equal to something that is equal to varchar max, it'll give you an implicit conversion. Or var binary 800 compared to a variable that's set to var binary max, you'll get implicit conversion. And certain number data types do that too. So anything that has a precision like float, decimal, or money, they all are numbers, right? That should work fine with all the integer data types. Nope. Those also provoke implicit conversion. So let me just show you in another quick demo in case you've never seen this before. All right, let's see here. Let me go over here to this server. This is a SQL Server 2017 where I have AdventureWorks installed. And let me copy over a bit of text here. So just to demonstrate some implicit conversions, let me see if I have this table already. So I'll just try and do an insert. Nope. Okay. Oh, cannot insert duplicate. Yeah. All right. So I believe I have these tables already. So notice here, I've got a product category table, and category ID is an integer. Then I create another table called product, and it has category ID as varchar 10. Insert some data into these tables. And now I want to get data out. So let me turn on my execution plans here. And I have declared the category variable as an integer. And so when I try to do a selection against it using a join, let's take a look at the execution plan. Notice here, there's a warning, and I couldn't do a clustered index scan on the table where it was defined as a varchar, varchar here. Hello? Somebody unmuted there. Sorry about that. I couldn't do a scan because I couldn't do a seek rather, because anytime you invoke a function call against a indexed column, it can't use the index on that column. So because it basically thinks we're doing a cast function on it, it can't use it. So you can see that these implicit conversions are pretty pretty insidious. And if I go back to the earlier query, one of the earlier pieces of code I opened, let me actually look at my recent files here. I think it was for the database design. I actually had a piece of code in here written by Jonathan Cahias that will reveal if you have implicit conversions that are sitting in your plan cache. And so you can run this in production. It's not harmful for you. It could take a while if you have a really big allocation of RAM for that SQL server, but this will let you know if there are issues there, okay? And so that's something to be aware of. All right, so let's see here, SQL code quality. Here we go. So let me show you a few more red flags about SQL code quality. One that I like to look at is a perfmon counter called deprecated features. And it's not widely known, but it's really, really useful if you're gonna kind of uplift some code from, let's say SQL Server 2008 to SQL Server 2016. Well, you probably want to know what kind of old-fashioned things from the 90s that you're doing on that database, or the vendor is doing on that database, and whether it's significant enough that we should actually do some new coding. So that's one thing I always like to look at. And then I like to look at if there's any over-reliance on some of those problem feature sets that I mentioned, like triggers, CTEs, cursors, or temp tables. So I've got some code in here that shows you how many of these different kinds of objects exist in your database, so that you could take a glance and see, on the whole, whether they're balanced or over reliant on these particular strategies. So here we can see some triggers of different kinds, and they're actually, not bad. One or two, not a big deal. Another thing to look for is plan reuse. If you've written your code badly, you may have lots of execution plans. And in this case, I know in my database, I do have lots of execution plans that are only invoked one time. If that's the case, I might consider looking at other ways to write my code. We do have some presentations on centuryone.com/resources about this topic. Or you might also want to enable the optimize for ad hoc workload database level option. And this can really greatly improve your execution plan reuse as well. Here's a check for how many active cursors you've got. Here's a check for lots of GUIDs, if you have too many GUIDs in use, and if you're using them as your clustered index. Fortunately, none in these databases have that. Too much cursors, too much tempdb, and so forth. So a lot of things to check for in your database design. All right, system settings. There are a few system settings that are surprising and people don't realize it. One thing, for example, like if you set compatibility level on a database, SQL Server actually doesn't, what compatibility level does, it doesn't say run my SQL Server 2016 database as if it was a SQL Server 2012 database. It doesn't make it run that way. What it does is it makes sure that the Transact SQL will compile and execute the way it did in 2012. So that's definitely something to keep in mind. It changes the T-SQL behavior, not the entire engine, okay? And optimize for ad hoc workload. Again, that's one you may want to utilize. It changes the way SQL Server caches the execution plans and gives you a lot more space in the plan cache. I actually always enable this because I've seen it help most of the time, and I've never, ever seen it hurt. Another thing here, max degrees of parallelism and cost threshold for parallelism. It's a commonly evangelized idea that the cost threshold for parallelism default, which is 5, is bogus. Typically, I recommend you set it on 30. Others of my friends, Brent Ozar, I think he's recommending you put it on 60. But in either case, 5 is way too low. What that number says is wait this number of seconds, or I'm sorry, if you think, Mr. Optimizer, if you think the query will take more than this number of seconds to complete, go ahead and try to parallelize it. And I encourage you to actually set this value, and if you have a very large SQL Server in terms of the number of CPUs, also change the max degrees of parallelism. So if you change this to 30, that means it'll only try to parallelize really big queries that take more than 30 seconds to run through the optimization process. But the next question is, how many CPUs will it use if you parallelize it? The answer is, if you leave it at the default, SQL Server will try to use all the CPUs for the parallelization. And what if you've got 128 CPUs, like the case at the beginning? Don't do that. Instead, set this number to something moderate, like 8 or 16, so that when it does parallelize, it will go no higher than the number you've put in this configuration setting. And that's really powerful. That enables you to make sure that all the other things that are going on that SQL Server get their shot at a fair number of CPUs to do parallelism. So let me switch over, just because I'm running short on time. I'm not going to go into too much detail on the other things there, but let me switch over and show you a little bit more in the demos here. And this is on system setting red flags. You definitely want to check this website out, by the way, SQL Server Performance.wordpress.com by Glenn Berry. He keeps these up to date, his SQL diagnostic queries for all versions, all service packs, all cumulative updates of all the different versions of SQL Server. So really awesome stuff. So here I'm looking at things like backup compression default. I really do want SQL Server to back up compress all of my backups. I do want SQL Server to have a number around 30 for cost threshold for parallelism. So there are some numbers in this list of things you'll want to see changed upward, but then there's others that you will want to make sure are still sitting at 0. For example, lightweight pooling, priority boost, those should definitely be 0. You don't want anybody messing with those. They were useful back in SQL Server 4.21a and SQL Server 6. Don't use them now. Also, you'll want to see if trace flags are active on your system. Unless you have a reason, these are the trace flags I recommend running. Anything else probably needs to be warranted. It needs to be kind of double checked and make sure that you need that. If you don't know how, here's how to see any trace flags you have active on your system. And I currently do not have any, so you're not going to see anything there. Here's a quick check on your database level settings. So this can show you important things about your SQL Server. I was going to say, I think this is actually set up to run on later editions of SQL Servers. Let me run it here not on my SQL 2008 R2. Let's see what we get. There we go. So here's all the different databases and how they are set up, if perhaps they have a different compatibility level. So, good stuff to check. Another couple ones from Pedro Lopez. One is to find out all the error messages. And then later on, let me actually skip ahead. One that a lot of people don't know about is that SQL Server has a default location. Whoops, didn't find it. Okay. SQL Server has a default location for all of your, where are we? All of your stack dumps. And stack dumps are pretty serious. They're not to be toyed with lightly. Oh, okay. This is also for more recent versions of SQL Server. And so what you want to do is you want to make sure that you don't have a lot of these, and that what you do have are ones you know about and have dealt with. So here I can see I have had a lot of stack dumps. I don't know what I was doing on October 15th, but I had 5 or 6 that day. And so this will help you stay on top of system settings and system level issues that you're having with your SQL Server. Okay, so we're in the final stretch here. About 5 to 10% of your performance issues are usually due to hardware, the operating system, or maybe your virtual machine settings. That's under normal circumstances. That's barring ignorance or somebody who didn't know what they were doing when they were setting up the system. I/O is usually the biggest bottleneck, but memory does come up, so does CPU, so does network I/O for that matter. So I encourage you to read a bunch of the blog posts that Glenn Berry writes. He's our resident expert at SQLperformance.com on the topic of hardware. Database design issues are 10, 15% of the performance issues on a SQL Server. Indexing is the single biggest thing that will cause problems for you. But there's other things too. There's things like whether you're doing concatenated indexes, clustered keys or not. Most of it is sucktacular SQL. You know, if you're just writing bad code. SQLperformance.com and my buddy Aaron Bertrand, he writes extensively about Transact SQL best practices. And so you can find hundreds of articles on SQLperformance.com about it. Do this, not that. You know, use a coalesce, not a is null under these circumstances. And then finally, those system settings. Your mileage may vary, but if you go just with the defaults, you're shooting yourself in the foot. There's issues there. So with that, it's time for Q&A. I'm not sure if you've been using the Q&A feature, but go ahead and enter your Q&A, your questions in there. I'll try to answer what I can. What I can't get answered today, I will answer in email, and I'll also answer in a blog post. And then some final call to actions while you type in any questions you might have. First, let's get connected on social media. If you want these slides and these scripts, they're already posted. Just go to century1.com/K-Klein and you can see them there. A lot of my videos and scripts and slide decks, they're posted at century1.com/resources. I mentioned Plan Explorer. Everybody loves Plan Explorer. I love it. And then finally, as I mentioned, if you would like a 1-year seed license to SQL Sentry, Doc Express, Legitest, send me an email. I have the power. I will get you a hookup. You won't even have to pay maintenance. And after a year, it is a perpetual license, so you could keep it if you want to do that. All right, so with that, I'm gonna ask Leslie, do we have any questions?
We do. We absolutely do. Okay, I'm just going to go and start at the top. So we'll start at the beginning of your presentation. Where do I set processors to high power?
Okay, so it's, you know, if you've ever had a laptop, you know, where there's the little battery icon and you right click on it and it'll say, like on mine, by default, it will say, in fact, my sysadmins have set it so that I can only ever set it to balanced power. But in your enterprise, chances are you'll see that little battery icon in the start or, you know, in the ribbon at the bottom of the page in the lower right corner. So click on it there and you can change it manually. And if you would prefer to use PowerShell, then drop me a note. Next time I'll put it in the slide notes, but there is a PowerShell string you can use to reset that value as well.
Fantastic. Here is an excellent question. This person works at a place where when they install an instance of SQL, they use the formula memory installed on server times 1024 times 80% to the max memory setting. Is that a good way of doing it?
Yeah, absolutely. There are two kind of approaches to memory settings. One is, you know, kind of rule of thumb that gives you a quick way to pick that number. And then the other is a much more measured process where you validate how much memory the SQL Server actually uses and how many other processes are running and what memory they need. So that's really easy when you have a monitoring tool or you're really good with perfmon and know what to look at. That's the way to give yourself a foolproof number, right? On the other hand, most of us ain't got time for that. So there's the process or the method that the person said they use, that's a great way to go as a quick approach. Personally, what I usually do is I say, take the max memory, deduct 2 gigabytes for Windows, and then 1 or 2 gigabytes for each additional service, Windows NT service of significance that's running on the system. So if I have reporting services also there, then I'll say, okay, let's take 2 gig off for that. If I have integration services, then I'll also take 2 gig off for that. But again, I think you're probably going to get a very, very close number if you just say, let's take max memory times 80% and go with that number.
Okay, fantastic. Lots of kudos for great material. Again, this is being recorded, so we will have it posted. And like Kevin said, the scripts are available to you. One more question. We're seeing performance gains in almost all areas of our application when we change compatibility mode from 80 to 130. But a few areas queries literally time out. I don't see any obvious ugliness in the T-SQL code, so I'm stumped where to look next.
Yes. Okay. So what you're probably experiencing, and again, it depends, but if I was a wagering person, I would put money on the fact that the cardinality estimator and the version that you upgraded to is a new cardinality estimator. And so it's a lot of applications on their first upgrade to the newer cardinality estimator, they have overall much better performance, and then occasionally they have a hard regression where 10% of the execution plans don't work nearly as well. The bad news is I don't remember the exact, there's a trace flag you can apply at the query level that says, so I don't remember exactly what the trace flag is, but you can tell it, for this particular query, use the old cardinality estimator engine. It's still built in there, it just isn't used by default. Use the old one for this particular query. So if, and it sounded like you are able to identify the queries that are timing out, get those together, make one small code change to that query at the end that says DBCC trace on, you give it the trace flag number. And again, I apologize, I don't remember the exact number, but that engages the old cardinality estimator for that one query, and that should kind of get rid of that problem for you.
Okay, fantastic. We're going to go ahead and wrap it up. I know there was a few more questions out there, but I will be sending the questions off to Kevin and those responses, so he has those. Again, reach out to Kevin via social media. I'm sure he'll follow up with you if you do need answers to the questions that we did not get to today. And Kevin, thank you so much for joining us and kicking off our 2019. I think it's going to be a very cool year.
Awesome.
Yeah.
Yeah, I hope to come back sometime this year.
Excellent. Good. Would love to have you, of course. Thank you, everyone. Have a great weekend. Hopefully see you at Summit later this year. Thanks much. Bye, all.
Thank you. Bye-bye.